Hello, scholars, and welcome to our lesson on transformations and similar figures. This is in Transformations in Volume and is part 1. The goal is that you'll be able to identify whether a transformation is resulting in similar figures or congruent figures, and how to describe corresponding sides and angles. The reason we're doing this is that geometry, quite literally, helps to shape the world around us. Being able to understand and use the methods to move and change shapes is incredibly important to understanding the world around us. Let's begin. First, with a warm-up pop-up. Create instructions on how someone can take the shape to the left and then create the shape on the right. So you have all these shapes to use. What instructions would you list off on how to turn these into this image here? Alrighty, I am doing a check-in. There are a lot of different ways you can do this. One thing you might need to tackle is how do you discern what shape you're talking about in your instructions? You could call them by colors, you could assign letters to them. If I'm looking at, I'll say this is A, our first orange shape here. It looks like they move it up here, which means at the very least they turned it. So they turned it this way. And then they slid it over there to be the top of this little boat. We keep going, then the next part of the sail here is the blue one, which again, it looks like they rotated it. Rotated quite a bit too. And then slid it over to the bottom of the sail. You can keep doing this, right? We can say, all right, well, then I'll call this C. And they rotated a little bit and slid it over. I call this D. Same thing. They turned it a little bit and slid it over. If I want to call this one E, they moved it quite a bit, and then slid it over. And then we have A, C, D, E. We can call this one F. They turned a little bit, so it looked more like a square, and then slid it over. And lastly, we'd have what we call G. And G, same deal. They turned the shape a little bit and slid it over. As mentioned, there are a lot of different ways you list instructions on how someone turned all these shapes into this one. There's a lot of different ways that are all valid. As long as your instructions still include the fact that no matter what, for all these shapes, they had to turn them in some way and then move them over into position. With that, I'm going to clear this up. And let's talk about transformations, a big focus for this unit. A transformation of a geometric figure is a function or mapping that results in a change in the position, shape, or size of the figure. We have 4 main transformations. First, we have something that flips a shape. And when we're flipping a shape, we'll learn more about it later, but we call that a reflection. Next one is sliding a shape. So you can slide a shape up, down, left, or right to change its position. We call this type of transformation a translation. Then we have turning, which we did a lot of turning and sliding in that warm-up problem. So this will turn a shape around a center point. And we call this turning rotations. Last transformation is the one that shrinks or grows a shape, makes it bigger or smaller. So we have the B here. We could shrink the B down, not changing its overall shape, but the size of it, or we go the other way and enlarge and make it be a very big shape. We call this shrinking or growing a dilation. So reflections, translations, rotations, and dilations are the main things we'll be using to change shapes for this unit. Let me clear these up. So we can talk about the next thing, congruent and similar figures. When we transform a figure, those transformations we were just showing, either you slide it, you flip it, you turn it, or you make it bigger or smaller, we either create a similar figure or a congruent figure. First, similar figures. Similar figures can be created by flipping, sliding, turning, growing, shrinking a shape. In other words, all the transformations. We have reflecting, translating, dilating, and rotating. As we had here, reflecting, translating, rotating, or dilating. Those are all things that make similar figures. Now, within that, we have congruent figures. Congruent figures can be only created by flipping, sliding, or turning a shape, not growing or shrinking. Because the idea of a congruent figure is the shape itself does not change in size. So again, flipping or reflecting a shape makes a congruent figure. Sliding or translating a shape makes a congruent figure. Turning or rotating a shape makes a congruent figure, but shrinking, growing, or as we call it, dilating a shape does not make a congruent figure. It changes the size. It means it's no longer the same size shape. Let's look at a problem. This is determining if a transformation is congruent. It says, does the transformation to the right appear to make a congruent figure? Explain. And we have two words here, pre-image and image. And Oni, our geometry expert, is here to remind us that the pre-image is what we call the original shape. So it's a shape we haven't changed yet. The image is what we call the shape after it has been transformed or changed. Thank you, Oni. That means they're saying this is the original and this is after they transformed or changed it. Looking at this shape got bigger. That means they used a dilation. Though we were just talking about looking to see if it changed sizes, it got bigger or smaller, it did get bigger. We can also see, did it change shape? Like, did the angles change? Well, no, it still looks kind of like a square. But we can only say it's congruent if the same shape and same size were kept. When it gets bigger or smaller, we have a dilation, that means it didn't stay the same size. So if they're asking if this is congruent or not, we would say it is not. All right, they did say to explain though. It is not congruent. I can say, we'll go back one. The shape was dilated. They made it bigger. I'll say it was dilated, which changes the shape. It changes the size of the shape, which we cannot have if we're trying to make a congruent figure. There we go. It is not congruent. The shape was dilated, which changes the size of the shape. I'm going to clear this up and make sure you get your notes in if you don't already have them. But I'm going to move on to the you try, which means it is time to see what you know so far. Pause the video to try this problem on your own and resume when you are ready to check your answer. All right, doing a check-in. You had two problems, A and B. So, looking at A, it can be sometimes hard to tell an image and a pre-image, but they may have changed colors. They don't look like they change the same size, though, do they? If we want to get specific, it looks like it just got flipped over. So if you said for A that yes, it is congruent, you would be correct. On that note, they did ask you to explain. There's a lot of different things you could say. You could just say it stayed the same size. You could specify that because it was flipped or reflected, it was reflected, which when we reflect things, the size stays the same. So which keeps the size the same. The size stay the same, the angle stay the same, it's the same shape. So it is congruent. For the next one, looking here, again, it can be hard to tell sometimes, but it does look like we're dealing with the same shape. The pre-image with this triangle, the image, it looks like it is the same. And normally in problems, they'll make it be pretty obvious when it has changed sizes. Knowing that, it looks like it got both flipped, and then also actually looks like it got translated a little bit too. It's like they flipped it over and then moved it up. So again, if we said, yes, it is congruent, I think that totally makes sense. Again, they didn't say to explain. Your explanations can be different, but I would say that it was both reflected and translated. They flipped it and then they slid it over. But both of those, I'll say both, almost spelled which wrong, can't have that. Both which keep the same size. Same size, same shape. They just moved it over. If you said both were congruent, you were absolutely correct. If in your explanation you made sure to hit home the idea that whatever transformation they used did not change our size or shape, then you were also correct and good to go. Make any corrections you need to, but I'm going to erase this and go to our closing for part 1, which is that transformations change the position, shape, or size of figures by flipping, sliding, turning, or growing or shrinking a shape. Or they started mentioning flipping is reflecting, sliding is translating, turning is rotating, and shrinking or growing is dilating, which we'll use that vocab more in the future. All transformations create similar figures. So figures that are the same shape type. They don't really get wonky in that way. But if we're talking about congruent figures, only sliding, flipping, or turning creates a congruent figure, not dilating. The idea is congruent figures stay the exact same size and shape, which if you dilated a shape and made it bigger or smaller, you'd be changing its size. And with that, I'll actually see you in a moment for part 2 of this lesson.